This is the second section on hyperbolic functions, and this is inverse hyperbolic functions. Now, we know with the normal trig function, so sine, its inverse is arcsine, cos, arccos, and tan, arctan. So the hyperbolic functions also have their corresponding inverses. Now, sine is arcshine, but we don't put the C in, just put arcshine like that. Cosh is inverse, arcosh, and tanch, its inverse is going to be arc. Oops, I must put the extra C in there. Arc, tanch, like that. Okay, so these are the inverses. So over here we've got the graphs. Okay, now we know that when we find the inverse of a graph, we reflect in a line y equals x. So you can see that dotted line here on both the graphs. So the graph of the original function is in red. The graph of its inverse is in blue. So you can see for the shine graph, we don't need to make any restrictions on its Ranger domain for the inverse to be a function. That's fine. But for the Cosh graph, we need to restrict its domain so that we get an inverse, a function. Otherwise, if we didn't restrict the domain, so we had something like that, we'd end up with this. Okay, and that's not a function. So if we look at the original graph in red, what we have is a domain where x is greater than or equal to 0, and we have a range, you can see it, where y is greater than or equal to 1. So that means for the inverse, the domain of the inverse, well, that's going to be the range of the original function, is going to be x is greater than or equal to 1, and the range of the inverse is going to be the domain of the original function, which is y is greater than or equal to 0. Okay, so that is highlighted in the table down here. Now, the one graph that isn't there is arctanch, so let's do that. So I'm going to put the original graph for tanch in a similar colour to how they've done it, like that. And this crosses at 1 and -1. So the inverse will have asymptotes at 1 and -1, but on the x-axis, so let's put those in, 1, -1. So if that graph that we've got for tanch gets reflected in a line y equals x, we end up with something like this. Okay, so the red one, that's our y equals tanch, and the blue one here is our y equals arctanch. Now, if we look at the graph of y equals tanch, then what we find is that it never goes above 1 and it never goes below -1. Now, its domain, you can put in any x value you like. Yeah, so its domain is all real numbers, but the output only is stuck between 1 and -1. So you could say the modulus of y is less than 1. Okay, that's the same as saying that y is stuck between -1 and 1. So then if we look at y equals arctanch x, everything's going to be swapped around. So the x values that go in are stuck between 1 and -1. So you could say that the modulus of x is less than 1, which is the same as saying that x is stuck between -1 and 1. But the output values can be any real values. Yeah, so that completes the three graphs. Right, show that arc shine x equals that. Okay, so I'm going to write the definition for arc shine x over here. I'm sure that's going to be useful in a moment. And the first thing I'm going to do is I'm going to say let y equal arc shine x. Then I'm going to do shine x to both sides. So I end up with shine y, which looks like shiny, equals x. Now shine y, if I use the definition, so I'm basically using this over here, but with y's instead of x, and I will have x equals e to the y minus e to the minus y over 2. Right, let's times both sides by 2. 2x equals e to the y minus e to the minus y. I don't want a negative power, so I'm going to times everything by e to the y. So I've got 2x e to the y equals e to the y times e to the y is e to the y squared, or e to the y all squared, which is e to the 2y minus 1. Right, next step, bring everything to one side to make it look like a quadratic, which will give me this. Minus 1 equals 0. Okay, now I'm actually going to complete the square here, and I'll show you why it works. If I said let a equal e to the y, what I would have is a squared minus 2ax minus 1 equals 0. Now, if I complete the square on that, what I will have is a minus x all squared. Then I need to make an adjustment. So what do I get if I multiply this out? A minus x all squared, I will get a squared minus 2ax, that's fine. But then I'd get a plus x squared. So I need to take away an x squared, then I've got the minus 1 still there. So I'm going to apply the same process to this. But instead of a, I've got e to the y. So I'll have e to the y minus x all squared, take away the x squared that I don't want, minus 1 equals 0. So from there, I'm going to move the x squared and 1 to the other side. I'm going to square root both sides. Don't forget you have a positive and a negative. And then add x to both sides. So I'll have x plus or minus square root of x squared plus 1, like that. So if I want to find out what y is, then I would do log of both sides. So y equals the log of x plus or minus square root of x squared plus 1. Now, can we leave it like that? Well, let's have a think about this plus or minus. Yeah, this bit in the bracket here is not allowed to be negative. Okay, can't be negative. You can't do the log of a negative number. Now, is it possible that this could be negative? Well, if I'm doing x minus something that's bigger than x, bigger than x, I'll end up with a negative. X minus something that's a bit bigger is going to be a negative. Now, x squared plus 1 square rooted is always going to be bigger than x, because you're not just squaring x and square rooting it again, you're adding 1, then square rooting it. So x squared, the square root of x squared plus 1 is always going to be bigger than x, so you can't do the negative. If you did an x minus that, you'll end up with a negative number. So we only have the positive square root. So I'll have the log of x plus x squared plus 1 as required. Now, when you do this type of question, you'll probably need some explanation as to why you can't put the negative. So if you said something like x squared, square root of x squared plus 1, let me write it down. What you might want to write down something like this. So since square root of x squared plus 1 is always going to be greater than x, therefore we take the positive square root to ensure the bracket is positive, or something like that, just so that the examiner knows, right, you can't take the negative square root. Okay, show that arc cosh x equals the log of that. So this is going to be very similar to the last one that we did. So first of all, let's write down our definition for cosh x, which is e to the x plus e to the minus x over 2. So the first thing we're going to say is we're going to let y equal arc cosh x. We're going to do cosh x to both sides, or cosh to both sides. That will give us cosh y equals x. Let's just flip that around. So you've got x equals cosh y. Now we can use the definition for cosh x to do cosh y. So that will give us that x equals e to the y plus e to the minus y over 2 times both sides by 2. So we've got 2x equals e to the y plus e to the minus y. Then we're going to times both sides by e to the y to get rid of that negative power. So we get 2x e to the y equals e to the y all squared, which is e to the 2y, plus 1. So we just got plus 1 instead of minus 1. We're going to bring everything to one side, so it looks like a quadratic. So we've got e to the 2y minus 2x e to the y plus 1 equals 0. Now we're going to use that same trick as last time to complete the square on this. So in the brackets we will have e to the y minus x all squared. So I know that if I multiply this out here, just to show you, I would get e to the 2y minus 2x e to the y plus x squared. So I don't want the x squared, so I'm going to subtract x squared to make it balance. Plus 1 equals 0. So the only difference with the previous one is that here we've got plus 1 where we had minus 1. That's the only difference. Everything else is the same. So from there, let's move the x squared and 1 to the other side. So I've got e to the y minus x all squared equals x squared minus 1 rather than plus 1. We're going to square root both sides. So we now have e to the y minus x equals plus or minus the square root of x squared minus 1. Let's straighten out that square root sign. From there, we will add x to both sides. So we have e to the y equals x plus or minus square root of x squared minus 1. X squared minus 1. Do the log of both sides. So we'll end up with y equals the natural log of x plus or minus the square root of x squared minus 1. Now, just like before, we need to make a choice between this positive and negative, because you'll see in the question, actually it's only the positive square root. So can we work out why? Well, for any value of x greater than 1, what happens is that if you were to do x minus the square root of x squared minus 1, you always end up with a small number. Okay, you actually end up with something less than 1. Here's an example. What if x were 50? Okay, so let's work out 50 minus the square root, 50 squared minus 1. So if I work that out, 50 minus square root 50 squared minus 1, I end up with 0.1 basically. 0.1. Okay, and in fact, as x gets bigger, this result gets smaller. Now, what happens when you do the log of a negative number? Sorry, not a negative number. The log of basically a decimal. Yeah, in other words, a number which is greater than 0 but less than 1. Okay, what happens is you get a negative result. A negative result. So I'd end up with y being negative. Now, that's not allowed. If you remember the graph of arc-cosh, let's draw it here. The graph of arc-cosh went like this. Yeah, there's no bit of the graph down at the bottom. Yeah, it starts there. Y was always positive. So for that reason, we take the positive square root and not the negative one. So y equals log x plus the square root of x minus 1. I don't think I did this on the last one, but we can just replace y with arc-cosh x. Arc-cosh, too many c's again. Arc-cosh x equals log x plus square root of x squared minus 1. So these results we've worked out, we can take them for granted. Yeah, so they're in the formula book for us to use, but you may be asked in the exam to prove them from scratch like we did like before in the last two examples. So we are going to use these to help us work out the exact value. So arcshine 1, what we do is we just substitute 1 into the formula like this. We're asked for exact values. Our calculator is probably not going to give us an exact value. Probably not going to give us the answer as log something. Right, so what have we got? basically log of 1 plus root 2. Log, natural log 1 plus root 2. Second one, r cosh 2, so we substitute 2 into the formula, so we've got log 2 plus 2 squared minus 1. So then we get the log of, it's 2 plus root 3. So exact values here. And then C, we're at for arctangent a third. We'll put a third into the formula, so it's a half. Log, that's there already. And then we've got 1 plus a third over 1 minus a third. So that's half log. So that's going to be 4 thirds at the top divided by 2 thirds at the bottom. So half log 4 thirds divided by 2 thirds. I'm being lazy again, using a calculator. Gives me 2, like that. So you could leave it as half log 2, but the half can be brought to the front as a power. So you get log 2 to the power half, or you could say log root 2. Okay, so you should now be able to do exercise 6b on page 125 of the textbook, and all the important information is here. Apart from the graphs, you can always go back and have a look at the graphs that were on that first slide.